Okay, so I think I figured this out using Prim's algorithm. So it says to start at vertex B. So we cross out the row of B and we put the 1 above the B column. And now we circle the lowest number in that column. That's easy enough. Okay, so then we cross out that row F. We put a 2 above the F column. Now here's where you have options. The algorithm says you can choose the lowest number in any of the numbered columns. So column B and column F, I can choose the lowest number in any of those, and we can see there's actually 3 of them that are tens. And so I can choose any of those, and it should work out the same. So if I just choose, but I'm only choosing from those numbered columns. So if I just choose this one, then I would cross out the D row, and I would put a 3 above the D column. Now I do the same thing. I choose the lowest number in any of the columns that I have numbered. So the lowest number in this column is a 10, but the lowest number in the D column is a 9, and that's the lowest number overall of any of the columns that I've numbered. So that corresponds to A, so I cross that out. I put a 4 above the A, and now I can include the A column, which has the lowest number of any of the numbered columns left. 8 is the lowest one. So now I cross that row out. I put a 5. Now I can include the C column, but C has a 14, and that's not the lowest. That's not the lowest one. There's only one row left, so I just pick the lowest number is 12, and I can choose either one of these. It doesn't matter. So now I add all these numbers up. 6 plus 8 plus 9 plus 10 plus 12 is the 45. Okay, and it wouldn't have mattered if I picked, let me just erase, start over again, and show you, because why won't this erase? At that other step, I could have picked a different 10. I just want to show that it would work out the same way. So we start at vertex B, we cross it out, we put a 1. We pick the lowest number in this column because it's the only column we've numbered. So now I have to cross this out and put a 2 there. Now I can choose any of these 10s. Okay, I forget which 10 I chose now. Let's choose this one. I know I didn't choose that one. So now I choose that 10. So I'm going to write these numbers down over here. Now I have to cross out this row, and that corresponded to, wait, now I'm lost. If I choose that 10, it corresponds to A. So now I put a 3 above the A. So now I can choose any numbers in columns A, B, or F. And I have to choose the lowest one in any of those columns, and the lowest one is 8. So then that corresponds to C, so I have to cross that out, and I put the next number in order above C. Now I can choose the lowest number in any of either A, B, C, or F. I can't choose from D or E. So then the lowest number in any of those columns is a 9. Okay, and that corresponds to D. So D gets the 5, and now I can include the D column. The lowest number in any of those columns is a 12. It doesn't matter which one I pick. And here we have the same numbers, just in a different order because of the 10 that I picked. I could have chosen any of those 10s. I hope that is making sense. It's starting to make sense to me now. So that is Prim's algorithm.